All right, let's try an example. Example 4.1.4. Let V be P2, so polynomials of degree 2 or less with the following inner product. We haven't proven it's an inner product. We might do so in the worksheet, but let's just assume it is. So PQ is the integral from -1 to 1 of the product. All right, show that P and Q are orthogonal. So P is X and Q is X squared. So let's look back at how we define angles. So we have our cosine of an inner product over the length. And then here, orthogonal means the inner product is 0. So that's all we have to do here. So we want to check what P and Q gives you. So that's the integral from -1 to 1 of x times x squared. So that's the integral of x cubed, which is x4 over 4 from -1 to 1. We get 1/4 minus 1/4. And so we get 0, so yes. All right, so same as what we did in linear 1, but it's just that the dot product is more complicated or more strange. It could be anything. All right, find the angle between P of x, which is x squared plus 1, and Q of x equals x plus 2. All right, so we're going to use that theta is our cos of PQ, and then length of P, length of Q. So we're going to have to compute all three. So let's start with PQ. That's the integral from -1 to 1, x squared plus 1, x plus 2. All right, so we expand it. I got x cubed plus 2x squared plus x plus 2. Then you integrate it, you get x4 over 4 plus 2x cubed over 3 plus x squared over 2 plus 2x, and I'm going to plug in -1 and 1. I actually already computed it, so let's use my computation. I got 16/3. You also have to compute PP so that you can find the length of P, and you'll need QQ for the length of Q. So PP will be the integral, sorry, of x squared plus 1 times itself. Again, you expand. I got, I guess, x4 plus 2x squared plus 1. And then you integrate, that's x5 over 5 plus 2x cubed over 3 plus x from -1 to 1. Let me do this one completely. That way I'll have done 1 plus 2/3 plus 1 minus a fifth minus 2/3 minus 1. And so I get 2/5 plus 4/3 plus 2. And so that's over 15. That's 6 plus 20 plus 30. That's 56 over 15. All right, so let me just give you what I got for QQ. That was 26/3. And so theta would be our cos of PQ, which was 16/3, over square root of PP, so 56/15, square root of QQ. And so that's about 20 degrees. All right, so we have a lot to compute a single angle, right? These lengths look simple, but they really mean, in this case, an integral to compute. All right, so note that the angles between elements and orthogonality of two elements depend on the inner product. They are not intrinsic to the vector space. To illustrate this, we'll consider the same two polynomial as in 4.1.4a. So that's this problem here, but with a different inner product. So that p of x and q of x are not orthogonal in P2 when we use the inner product here. So I need, again, to find the inner product. So that's going to be p of minus 1. So that's minus 1. Q of minus 1 is minus 1 squared. 0, 0 squared. 1, 1 squared. Oh, it's a different one than the one we had above. That's fine. That's still an inner product. 2 squared. Here I'm getting 1 plus 0 plus 1 plus 8. So I'm getting 10. Oh, wait. Minus 1. Yes. So I'm getting 8. And so P and Q are not orthogonal. In fact, if you actually compute the angle, that would be, if you want to practice, you could use that one. That should give you arc cos of 8, root of 5, root of 18, which is about 32.51 degrees. All right, but of course that wasn't part of the question, so that part you don't need to do.